Okay, so we're starting the first book for 6.a. We have two books for 6.1. So we're going to do book A, expressions and orders of operation, order of operation. So here we have some patterns. Here's a pattern and here's a pattern. The left side, the left side is changing, and the right side is staying the same. It stays the same, plus 6, plus 6, plus 6. But the left side is just changing. And so what we do is when we have something that changes a lot, what we can do is simplify it and make it easy to write and say, this is always changing, but we must add 6. So we pick any letter we want and replace the changing side with a letter and say that changes, and then we add 6. So here, on this one, my left side stays the same, and it's my right side that's changing. And so whenever we have something that's changing, we can replace it with any letter we want. So say I like the letter, I don't know, R. We'll say R. This is staying the same, so I keep it the same, and I can replace it with a letter. I can use X. I can use Y. Doesn't matter what letter I choose. Okay, so here we have to do some vocabulary. Just like, yeah. So variables are just letters. So in math class, when we have letters, we call them variables. Okay, so here my X is the variable. The constant just means staying the same. So here's two terms here. They don't have any letters, so these are always going to stay the same. So you can see here the 10 stayed the same, the 6 stayed the same. So there's no variable next to it, so it's always going to stay the same. The coefficient is when I have a term that has a variable, a letter, a coefficient is the number that's in front of the variable. An expression is just like a pattern. Here's an expression, here's an expression, an expression, expression. That's an expression. They're just like, you know how we have English sentences? Math sentences. These are expressions, okay? So let's look at some examples. So here, but when we use algebra, we don't usually write the multiply. It sort of hides everywhere. Okay, so instead of going x multiply y, we just push it together and say xy. That really means x multiplied by y. We don't go 2 multiply x, we just squish it together and say 2x. And really there's a multiply hiding in between there. 3 times x plus 4, this is 3x. Take out the multiplication dot and just put it together. Here, if I want to say 5 times both of these things, I have to push the 5 so it's touching the bracket. So whenever you see a number touching a bracket, there's really a multiply hiding inside there. Okay. So now it says identify parts of the expression. So the variable, that's the letter. So the variable in this expression is y. The coefficient is the number that's in front of the variable. So that's the coefficient. The constant term is the thing that always stays the same. So this 3 never changes. It's always plus 3. So that's my constant. And the expression is the whole thing. It's like a math sentence. Okay. So how do I write A times B? AB. Maybe pause the video so you can do this and then check it after. So 6 times x, 6x. 2 times n plus 5, 2n plus 5. 4 times all of this, you just write it with a bracket. That means 4 times all of this. So here's my expression, which is the whole thing. Oh, the expression. 10x squared minus 5. The variable, that means letter, x. So if I said, what letter are you using here? I'd say, I'm using x. I don't write the 10 or the squared. I'm just saying, what letter are you using? I'm using x. The variable is x. The The coefficient, that's the number in front of the variable. So that's the coefficient. So I just put 10. Oops. 10. And the constant term is the number that stays the same in the expression, that never changes. That's the subtract 5. Okay, let's go to the next page. So now we have like and unlike terms. So we're going to do some vocabulary. So we have sentences in English. I ran, 2 words. I love carrots, 3 words. The cat is black, 4 words. We have words, and we know they're words because they're separated by spaces. There's a space in between I ran, a space, I space love space carrots. Okay? So when I have terms and expressions, terms are the same thing as words. So here, there are 2 terms, like 2 words. Here, 3 terms, 3 words. Expressions are the same thing as sentences. So here's my expression, it has 2 terms. Here's my expression, I have 3 terms. Here's my expression, it has 4 terms, just like this sentence has 4 words. So terms in math are separated by add and subtract, just like words are separated by spaces. So you can say here's a subtract, so there's a term because there's an add. Okay. Now we have like and unlike terms. So like is like, what do we have in common? Okay. Things that are the same. Okay. So here, all of these are like terms because the variable, the letter, is the same, x. Here, the variable, each variable here is y. We don't care about the coefficient, the number in the front. We just look at the letter, the variable, all the same. Here, 1x, 2y's, 1x, 2y's, 1x, 2y's. So these are like terms. Maybe don't think common, think same. It's much easier. These are the same, okay? The unlike means not the same, okay? So they have different variables or different exponents. So here I have x, y. This one doesn't have an x. This one has 2 y's. So these are unlike terms. Here, these are unlike because this has x, y. This one doesn't have an x. This has 1x. This has 2x. This has 3 x's. This has 4 x's. So the x's are the same, but the exponents are not, and because the exponents are not, they're unlike. I don't care about the coefficient. They're all the same here, but that doesn't help you decide if they're unlike or like terms. Now, why do we care? Because we only can add and subtract things that are like terms. Okay, if they're unlike, we can't add and subtract them. All right, so let's look. How many terms? So remember, terms, there's 2 terms, 3 terms, 4 terms. They're like words. So here's 2 terms, 3 terms, 1, 2, 3, 4 terms, 1 term. Are they unlike or like? GH. Different letters, so they're unlike. HH. They're the same, so they're like terms. This has XY, this doesn't have a Y, so they're unlike terms. I have 2 X's and 3 Y's. 2 X's, 5 Y's. Nope, unlike terms because they have different exponents. 2 S's, 3 T's. 2 S's, 3 T's. Yes, like terms. Same variables, the letters, and same exponents. So here, how many terms? 2 terms. Just like letters. How many terms? 2 terms. Because they're separated by an add and subtract. Here, only 1 term because there's no add or subtract, so it's just 1 term. And here it's 1, 2, 3, 4 terms. Are they unlike or like? AB. So they're unlike. Why? Different variable. Okay, so that means the letter's different. Here, this has x, this has xy, so they're unlike because this doesn't have a y. X, x. And the exponent is hiding. It's 1 on both of them, so they are like because they have the same letter, the same variable, and the same exponent. We don't care about this coefficient in front. It could be anything. We don't even look at it. We only look at the letter and the exponent on the letter, the variable. This has 4 x's and 6 y's. 4 x's and 6 y's, so they are like because they have the same letter and the same exponent. That means we could add and subtract these. Who cares if this is a fraction? We don't even look at this in front. We don't look at the coefficient, the number in the front. So this has AB, AB, good. This has 8 A's and 3 A's. It's unlike because the exponents are different. ST, ST. This has 5 T's, 5 T's. This has 1 S. This doesn't have anything on the S. But what's the only exponent that can hide? Oh, 1. So they look a little different, but they're exactly the same. So they have the same variable and same exponent, so they're alike. Let's look at the next page. So it says, are they like or unlike? Okay. So these all have x's and same exponent, 1. So they are like. X, 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 x. Oh, that has 5 x's and that has 2 x's. These are unlike because they have different exponents. This has 3 A's, 3 A's. Oh, this has 3 A's. It just looks different. But that's okay. And that has 3 A's. So this is like. When terms are like this, that means we can add and subtract them. Can I add and subtract these? Yes. So they're like. They just don't have any variables, letters, but you still can add them and subtract them, but we consider these like terms. Okay, 3 x's, 3 x's, 3 x's, 3 x's. It's okay if the x's are at the front and then they're at the back. Let's check the y's. 2 y's, 2 y's, 2 y's, and 2 y's. So as long as they both have 3 x's and 2 y's, it's okay. So they're like. Nothing here. Okay. So circle the correct answer. So pause the video and you try and do this, and then we'll check your answers afterwards. These are like 2 x's, 3 a's, 3 a's, x, y, not the same. 4 x's, 3 x's, nope. X, y, y, x, this has an x, this has an x, good. Has a y, it has a y, so it's okay. It's okay if they're backwards and they flip them around. This has a c, this does not have a c, so they're unlike. Can I add and subtract these? Yes, so they're like terms. So even if they don't have the letters, these are like. 2 x's, 2 x's, 1 y, 1 y. It's okay, it looks different, but it's the same, they're like. This has an x, this has an x. We don't look at anything in front, the coefficient. We just look at the letter, the variable. Okay, so now you match your terms, pause the video, match it, and then play it to check to see if it's correct. Okay. I did funny lines so you can follow it easier. Okay.